This is page 17 in our notes. My colors are black and red. This is still a continuation reviewing 5th grade. We're going to work on multiplying fractions and multiplying mixed numbers, which will help us when we get ready to divide fractions and mixed numbers, because you're going to find out that the 6th grade standard on dividing, you're actually going to be multiplying. So this is really important that you understand this review of 5th grade standards here. So we're reviewing multiplying. We're going to multiply fractions and mixed numbers. And this is important because this is essentially what you do when you're dividing. So this is a good set of notes to pay attention to. A couple things, we've talked about it with ratios, but if I were to give you a sentence that says 3/4 of 1/2 is 3/8, and I'm going to circle the of and the is here because this is important. We talked about during ratios, of actually means multiply and is means equals. So if I rewrite this, I could say this is the same thing as saying 3/4 times 1/2 equals 3/8. So I want you to see that these are the same two statements. So what did we learn during ratios with this? We actually learned that of means, what does of mean? It means multiply. And is means equals. So good things to know to help us along the way. What I like to say when I am multiplying fractions, once I have the problem set up, I like to say simplify and multiply. So I'm going to put that in quotes. I like to say simplify and multiply. And that kind of helps me out. I like to simplify first so that I don't have such large numbers to multiply, but you don't necessarily have to. You could just multiply across and simplify at the end. What do I mean by simplify? You're going to be simplifying the diagonals, but you're going to multiply across. So simplify the diagonals, and then you're going to multiply across. And we're going to do lots of examples where you see that. Move this up here a little bit. So the first example I have is 3/8 times 2/5. Notice how when I did this example, I used the space, traced the blue line, another space to write my numbers. So what do I mean by simplify the diagonal? Simplify and multiply. You're looking across the diagonals just to see is there anything that could be smaller. In this case, 2 and 8 can both be simplified down to make them smaller numbers. If you divide both of these by 2, you can make them smaller numbers. 2 divided by 2, cross that out, it becomes a 1, circle it. And then 8 divided by 2, cross that out, that becomes 4. Circle it. See how we made those numbers smaller? Instead of 8 and 2, we have 4 and 1. 3 and 5, you can't simplify down. There's nothing you can divide them both by. So I'd like to circle the 3 and the 5. So what do I mean by multiply? You multiply across 3 times 1 and 4 times 5. 3 times 1 is 3. 4 times 5 is 20. And there's your answer. And that's using the simplify and multiply. Or some people would just like to multiply across and simplify at the end. So what would that look like? 3/8 times 2/5. Same problem. If they just multiply across the top, multiply across the bottom, 3 times 2 would give them 6 on the top. 8 times 5 on the bottom would give them 40. 6/40 you would have to know could be simplified down. So you could divide them both by 2. And when you divide them both by 2, there's where you get the 3 out of 20, which was our first answer. I like simplifying first so I don't have such large numbers, but sometimes this gets confusing to kids, so they just multiply across and simplify at the end. The problem with this is you may have really large numbers and you're not sure what can divide them by to make them smaller. So let's do another example. We're going to draw a line here. Let's take 1/2 times 20. Some people can see this, some people can hear it. 1/2 times 20. If I said what is 1/2 of 20, it makes it easier to hear. What's half of 20? A lot of people are like, oh, half of 20 is 10. To do this, showing the multiplication, because we know it's 10, then how does this work? 20 is a whole number. We would rewrite this. We would rewrite it as 1/2 times, and then 20 is a whole number, so you could put 20 over 1. I have the two fractions set up, so I'm ready to simplify and multiply. Dividing the 2 and 20, I can see they can both be divided by 2 to make them smaller. 2 divided by 2 gives me 1, and that's as small as I can go. These ones I can't do anything about. They're as small as they can go. 20 divided by 2, that becomes 10, and that's smaller. So now I'm ready to multiply across. 1 times 10, 1 times 1. 1 times 10 will give me 10 over 1, and I don't leave it like that. That's actually improper. 10 divided by 1 is just 10. And we knew that from the beginning when I asked what is half of 20, but there's the math that goes with it. Let's try another example. Move this up a little bit. The next example is 2/9 times 3/5. So 2/9 times 3/5. Writing it nice and neat, tracing the blue lines. Let me move this up just a little bit. So I have it set up, ready to go. Simplify and multiply. When I'm looking at my diagonals, do I see anything I can divide them both by? 2 is pretty small, and 5 is prime. We know nothing else goes into it, so those are ready. 9 and 3 can be simplified down. I can divide both of these by 3, and they're going to be getting smaller. 3 divided by 3 is 1. 9 divided by 3 is 3. I like to circle my numbers. It makes it easy to see what I'm getting ready to multiply. 2 times 1 on the top, and 3 times 5 on the bottom. 2 times 1 is 2. 3 times 5, 15. And I always like to double check at the end, is that simplest form? Yes, it is. And there's my answer, boxing my answer. So that's fractions. Fractions are pretty simple. You're just ready to simplify and multiply. The next thing I would like to practice is mixed numbers. And we're going to do a couple examples of this. So we'll start on page 17 here, and we'll move on to the next page. So if I ask you to multiply 2 and 2/3, watch how I write this. 2 and 2/3. The 2 takes up 2 lines, and the 2/3 is split, times 3 and 1/4. 3 and 1/4. I think it's easier to multiply when they're just in the fraction form. So we're actually going to make these mixed numbers and turn them into improper fractions. Do you remember how I make mixed numbers into improper fractions? I call it the check mark method. Some people call it the backwards C, where you have to multiply 2 times 3 and then add the 2. Multiply 3 times 4 and then add the 1. And then these denominators will be our denominators of our new fractions. So when I change this, I'm actually taking 2 times 3, which equals 6, but then I'm going to add 2, which gives me 8 as the top number, over that 3 is my denominator. So I have changed this mixed number into an improper fraction. I'm still going to multiply, but now I need to take this mixed number and change it into improper. 3 times 4, which equals 12, and when I add 1, that's where I get 13 for the top. What's my denominator up here? 4, that's my denominator here, and I'm ready to just simplify and multiply. When looking at the diagonals, do I see anything that could be smaller? 3 and 13 cannot go any smaller, so I'm going to go ahead and circle those. But 8 and 4 could both be divided to make smaller. Some people will divide by 2, but if I divide by 4, I can actually make them smaller yet. I can make this one right here, 4 divided by 4, I can make it a 1, so I like that. I like to cross it off once I've used it. 8 divided by 4 would give me a 2, and then I circle that. And now I'm ready for 2 times 13 and 3 times 1. 2 times 13 is 26. 3 times 1 is 3. Ooh, what's wrong with this as our answer? We do not leave this as an improper fraction, so we're actually going to change it back to a mixed number to finish our problem up. How do I change this back to a mixed number? I'm going to take 26 and I'm going to divide by 3. 3 goes into 26 8 whole times, which gives me 24. When I subtract, I get a 2. I make a fraction bar. The 2 comes up to the top over what I'm dividing by, 3. And my answer is 8 2/3. Same as this, but I've changed it from improper to a mixed number. We're going to do a couple more examples to practice multiplying mixed numbers. So I would like to turn the page and go on to the next one because I don't have enough room here. So that was page 17 in our notes. We're going to move on